Hi everyone, I'm Nozari from Carnegie Mellon University, and I'm going to be talking about whether taxonomic and associative relations affect word production in the same or different ways. Similarity is a really useful tool for us to better understand the cognitive architecture of various cognitive systems. And this has been especially true about the language production system. Pretty much everything we know about how language production works, we have learned about different kinds of similarity effects in speech errors and reaction times. For example, now we know that when you want to name a picture like cat, what happens is that you first activate the semantic features of cat. Those features activate the word cat, but also other words that have some of the semantic features in common with cat. And this is how you get a slip of the tongue that's semantically related to the target. Activation then continues further down in the system, activates phonology, articulatory phonetic features, and there is some feedback in the system as well. So I'm going to focus on just a part of the system, not to overcrowd the slide, and show you what happens with feedback. Say you have activation of some phonology, they send activation back to a lexical item, such as mat, and mat in turn activates its own segments. And so this is how you also get speech errors that are phonologically related to the target. So similarity in general is a really useful tool for us to learn about how the system is set up. Specifically, in recent years, there has been a semantic similarity effect that has taught us a lot about how language production system functions. This is called the semantic blocking effect, and it comes from a paradigm that's called the blocked cyclic naming paradigm. In this paradigm, participants repeatedly see and name a limited set of pictures that are either semantically related, like cat, dog, panda, or semantically unrelated, like cat, shoe, and pen. The common finding is that when you look at reaction times, this is from Tatiana Schnur and colleagues in 2009, and in blue you see RTs to the same words appearing in the context of semantically related words, and in pink, those words in the context of unrelated words. And you see that RTs are longer for the same words when they appear in the context of semantically similar items. This is called the semantic blocking effect. This effect is very robust, has been replicated many times, and two findings are of note here. One, of course, is that semantic relations generally induce interference in the production system. But further studies have also shown that the effect is robust against both passage of time and also insertion of the intervening items. So if cat and dog are separated by a longer period of time or by the insertion of an unrelated item like shoe, you still get the semantic blocking effect. So it was the second finding that has attracted a lot of attention and gave rise to incremental models of learning in production. The idea here is that every act of production changes something permanent in your system, so it's an act of learning. I'm going to show this by focusing on a small part of this model so you can see what's going on. Say you want to name the word cat. Semantic features of cat get activated, and so they activate not only the word cat, but also the semantically related word dog. Once the trial is complete, your system wants to learn something to make production more efficient next time. And the way it does this is that it looks and see, okay, cat was the right response, it should have been supported, dog was not the right response, it should not have been activated. So the weights in the system change in order to make the production of the cat easier the next time. Basically, the weights that supported cat get stronger, and those that supported the competitor get weaker. So next time, if you want to now name a semantically related item like dog, you can see that it's at a disadvantage because its weights to its features have been weakened. So this is how you get the semantic blocking effect. But there is also this primary finding, which kind of got lost for a while in the middle of so much attention that the incremental learning models got. And that was the claim that semantic relations generally induce interference. But semantic relations can be of different kinds and flavors. For example, take an item like car. You could say that car is similar to bike because they're the same kind of thing. So we call this taxonomic relation. They're the same, they belong to the same category of items, they have the same features, they have the same function, etc. But you could also say that there is some similarity between car and road, but not because they are the same kind of thing, but because they are often associated with one another. They appear in the same context. And so this has sometimes been called thematic relations. And so the idea is that we know how taxonomic relations work, mostly when you talk about semantic blocking effect, what people use in terms of items or items that are taxonomically related together. So you could put car and bike instead of cat and dog, and you can see how you would get the same dynamic of weight changes such that naming bike after car would be more difficult than naming bike after an unrelated item. So now the question is, can we basically stick thematic relations into the same general framework and pretend like they behave the same way as taxonomic items? So doing that would look something like this. So you would just add the common theme as a feature, and you would put the word road in the same system. So now what you would expect, if the same kind of dynamic operated on road and car as car and bike, then you expect to see road interfering with the production of car, just like bike would interfere with the production of car. So have people looked at this? Yes. And the results are very non-homogeneous. So some people have found interference with thematic relations, some people have reported facilitation, and some people have found null effects. When you look a little more closely at these studies, you see that one problem is that there is no real objective definition of thematic relations. So people usually think about things that go together that are not exactly the same kind of thing. At the same time, taxonomic relations are sometimes not pure taxonomic relations. Think about words like cat and dog. They definitely belong to the same category. They do have a taxonomic relation with one another, but at the same time, they're often seen together and appear in the same context. A lot of people have both cats and dogs as pets, for example. So the relation is not pure taxonomic. It has some thematic component to it as well. So if we really want to understand whether thematic relations and taxonomic relations behave the same way, the first step is to have some objective, quantifiable measures and to get materials that are doubly dissociated. So you would want materials that are really highly taxonomically related, but not associatively related, and vice versa. So what we did in this experiment was to do exactly that, to find quantifiable measures of taxonomic and thematic relations. For taxonomic relations, we use Resnick scores, and we derive these from the WordNet. So WordNet is this really fabulous resource with hierarchical trees like this. So these are trees that really respect taxonomic categories. So you can see that, for example, animals are there are like different categories of animals, and under those categories there are subcategories of animals, and so on and so forth. And so you could quantify how similar two items are by following this tree and seeing, for example, turtle and snake are more similar than turtle and mammal because they share more nodes in the tree. On the other hand, thematic relations are a little harder to quantify, but the key point is that they are often very closely linked to associations. In fact, we now know from the field of distributional semantics that you could reconstruct the whole body of semantic knowledge by looking at the associations between words. And so the idea is that words that go together usually signify concepts and themes that go together. So the best way to quantify thematic relations is by looking at association measures. And so for this, there are a number of ways to quantify associations. We use two measures, pointwise mutual information and log likelihood. The reason we choose 2 is because they have different biases towards low and high frequency words. So it's nice to get both and make sure that your materials really score consistently with different measures. We use the NLTK from Python to do this on the sublex US corpus, and we vary the window again to make sure that our measures are not cherry-picked by a specific window. And so this way, we construct materials that either score very high on Resnick scores and low on association measures, that's our taxonomic block, or score very high on association measures and low on Resnick score, that's our thematic block. So the task is the word pair task, which we have used in a lot of different studies before. It's a really simple and useful task for looking at the effects of similarity in production. At the beginning of each block, participants see the 2 pictures that appear in that block. They see their names, they get practice with that. And then over the next 12 trials, they see one of the 2 pictures on each trial, and they just have to name the picture as quickly and accurately as they can. Blocks, the structure of the blocks looks something like this. So we always have the same target being compared to itself, so it's fully controlled in a within subject design, paired once with a taxonomic second picture, so you can have cow and bear as the 2 pictures, once with an associative or thematic picture, cow and milk, and once is controlled with an unrelated picture, so we can have cow and pen. And we have a number of different pairs, and participants basically complete all of these blocks. Accuracy is pretty high on this task in adults, and error rates are comparable across different conditions. So I'm not going to show you that, but I'm going to show you the RTs. Another thing we have calculated, I'm not going to show you our durations. I think it's really important to look at both RTs and durations because they could trade off. Our durations were very, very similar across the 3 conditions. So the effect of RTs are good measures for us to look at these data. We always analyze the data with 2 measures. Here we have multi-level models and non-parametric tests, the results converge. What you see here is that we replicate the canonical effect of taxonomic interference compared to the unrelated block. The effect is significant, but interestingly, you do not see the same effect for associations. If anything, the direction of the effect is the opposite and it's marginal. When you look at taxonomic effects and compare them directly to the associative or the thematic blocks, they are statistically significantly different from one another. And here I basically plotted the same thing by all the trials in which the target appears, and you can see that the trends are also consistent. So the red line is almost always above the gray line, and the blue line is on the other side. So taxonomic relations do create the transient facilitation. I don't have time to go over this. Ask me about this if you want after the talk, followed by the lasting interference that has been observed in the previous papers as well. But there is no evidence that thematic relations behave in the same way. So what does this mean for the cognitive architecture of the language production system? It means that thematic relations cannot be represented in the exact same way as taxonomic relations. So if you either this kind of model doesn't work at all, or if there is such a relation, the same incremental learning processes that operate on features of taxonomic categories do not operate on thematic categories. Or more likely, the system is not even set up this way. Maybe it's more reasonable to think of associations as direct links between lexical items and not links through some features. And so this would then bring up the really interesting question of whether there is really competition at the lexical level. And so if you are interested in that debate, I'm happy to talk about that after the talk. I want to thank my student Delaney McDonough, who collected these results, and my colleague Anna Fisher, who helped us a lot with extracting these measures, and also NSF, Spencer, and McDonald Foundations for supporting this work.